Hi, sorry this is super unprofessional, but nothing else would work and this is my last option, so just bear with me through my shaky hand and we will start. So today we're going to discuss the science behind how the camera works. The first component we're going to analyze is the flash. The purpose of the flash is to illuminate a dark scene so that if you're in a dimly lit room or it's nighttime, the image is still visible. It can also be used for quality altering when it comes to light and capturing the littlest details. You can tell by the final outcome of the picture that an image taken on a professional camera is much clearer than an iPhone quality camera. The physics behind this flash is what I'm going to explain next, and if you look on slide 2, here we go, you can see in the second picture what the flash of our camera looks like. To start off, like every circuit in physics class, there is a battery that is powering the operation. Free-flowing electrons flow through the circuit, which is actually in this case a gas discharge tube containing xenon gas with electrodes on the ends and a metal trigger plate in the middle. If you look again on slide 2 at the first picture, you can see the real-life gas discharge tube. So the electrons flow from one electrode to the other, which then energizes the xenon atoms. If you go to slide 3, here it is, you can see a basic diagram of where the electrodes are located. Then this causes the atoms to emit a light photon due to the electrons jumping further from the nucleus for a split second before coming back to its original spot. The split second that the electron is jumping back towards the nucleus is when the extra energy is released for the light photon. I've also included a diagram on the third slide of what the overall circuit looks like, and it's much more in detail than what we've talked about today, but I like how it shows the battery, the gas discharge tube, the trigger plate, and how it all comes together to create the phenomenon called the flash. Okay, the next component that we're going to talk about today is the film and how a camera captures an image. So, the film is a spool of flexible plastic that is coated with chemicals that are sensitive to light. They are kept in a light-proof cylinder inside of the camera. When you press a button on the camera to take a picture, the two little plastic pieces covering the lens are momentarily pushed back, letting light enter. The light causes a reaction in the chemical-coated film. In slide 5, you can see the film as well as the coated layer of this film. Here it is. I'll give you a little bit of time to look at it. The heart of a film is called the base. It is thick because the coating holding it all together is mostly made of gelatin, which you know what gelatin is made of, and it's super gross, but whatever. Moving on. There are many different layers coated on this film. Some are there to filter the light or to control the chemical reactions while the images are being processed. The layers that are for the purpose of forming images have these extremely, I can't stress this enough, extremely small grains of silver halide crystals. These crystals are photon detectors, which means that when they are exposed to electromagnetic radiation, they undergo some major chemical changes. They can process not only visible light, but infrared radiation as well. The silver halide grains are made by combining silver nitrate and halide salts in complex ways. This combination results in a range of crystal sizes, shapes, and compositions, which is the makeup of the crystal. These grains are then chemically modified on the surface with spectral sensitizers, which increases their sensitivity to blue, green, and red light. Oops, sorry, I started drifting a little bit. If these chemicals were not added, the grains are only sensitive to blue light, which you would know. This would not be very useful for a camera if only blue light was captured. So the chemicals modify, oops, sorry, I got a low battery. Okay. So the chemicals modify the sensitivity to other lights. These spectral sensitizer molecules have to attach to the grain surface, and when a photo is taken, they transfer energy from a colored photon to the silver halide grains in the form of a photoelectron. That is the end result, the photoelectron. And that is how the image gets captured and how we can enjoy colored pictures today. And yeah, that is my presentation. Thank you for watching. Sorry about the shakiness. Sorry about my little commentary at the middle and the end. But have a great one. Thank you.